step one, what do we do?
You determine the balanced equation.
Balanced equation. So, in this equation, it stated what the reactants were. What were the reactants?
Magnesium chloride react with silver nitrate.
Magnesium chloride and silver nitrate. Okay. There's something wrong with both of these. What's wrong with this one?
You need a 2 up there.
Good job. What's wrong with this one? Yep, exactly. Well done. So, when you look at these reactants, what kind of reaction type would this be? Double replacement. So, cation, anion. Your anions will switch. It gives you magnesium nitrate plus silver chloride. We have to use our solubility rules to determine the state of matter of each.
I'm going to leave you with that one.
Somebody took it.
Okay.
It happens every day.
Okay.
So, nitrate is aqueous, and then chloride is aqueous unless it's bonded to silver. So that's going to be solid. Thank you.
I'll leave it out.
Silver, there's other exceptions. Silver is one of the exceptions, and since right here chlorine is bonded to silver, it's going to be insoluble, so we're going to call that solid. Now, it says that we're going to produce 2 grams of a precipitate, right? When you have a precipitation reaction, you mix your 2 aqueous solutions and a solid forms. That solid is your precipitate. Did you have a question?
I'm pretty sure I'm just jumping the gun. So
Okay. Okay. Gotcha. Is this balanced?
No, that's that.
Is it balanced now?
No,
Oh, did I miss something?
magnesium and
1 magnesium, 1 magnesium,
yeah, and then
2 chlorine, 2 chlorine, 2 silver, 2 silver, 2 nitrate, 2 nitrate. Silver is +1, nitrate is -1. So, all right. We're trying to produce what now?
2 grams. 2 grams.
2 grams, exactly. And this is just like your lab. You're trying to produce 2 grams. Now, our scale, if you go over there and put something on that scale, it's like it goes to point something something. So since our scale is to the 100th place, 2 grams actually looks like this. Okay? And that's important because of significant figures. So we're trying to produce 2 grams of our precipitate. The solid is our precipitate. So 2 grams of silver chloride. And then the third step is to use our flow chart. The first equation is 1 mole over molar mass, right? So a mole of silver chloride over the molar mass of silver chloride. What's your question about the flow chart?
Yeah, there you go. That's the word. When do you use the number?
Molecules. If it says, how much of your reactants would you need to produce 6.023 times 10 to the 23rd molecules of?
You know what I did? I forgot to put the moles of the molecules. I kept thinking that was it. But I never used it.
You didn't need it because you already know what you're doing.
Oh, yeah.
Gotcha. All right. So the molar mass of silver chloride, what would that be? 143.32 grams of silver chloride. What would our next conversion be?
Yeah, mole B over mole.
Mole B over mole A. So over here, mole A is what we know, what we start with. So that's going to be silver chloride. Mole B is what we're trying to determine, and we're trying to determine two things. We're trying to determine how much magnesium chloride we need, and then how much silver nitrate we need. So we're going to do it twice. Let's just go with magnesium chloride for the first one. So 1 mole of magnesium chloride over 2 moles of silver chloride. So we've converted from silver chloride, grams of silver chloride, to moles of silver chloride, to moles of magnesium chloride. Yeah, you need the molar mass of what we're looking for, which is magnesium chloride. So we need to get the molar mass of magnesium chloride. So magnesium is 24.3050. That's going to be 2 chlorines. Seventy point 70.9 plus magnesium. Oh, you got it already? All right, 95.211 is what you said? Grams of magnesium chloride, moles of magnesium chloride. And then we've canceled moles, so now we're just dealing with grams of magnesium chloride. We just need to punch it in. So who gets stuck on plugging it in the calculator? Good. So when we plug it in, 2, are we going to multiply or divide by 143 point? Divide. Well, we're dividing because it's on the bottom. And then are we going to multiply or divide by 2? Divide because it's on the bottom. And then are we going to multiply or divide by 95.211? Yeah, we're going to multiply. Oh. Got to be polite and use those parentheses. And then I got 0.66433458. Good job. So 3 sig figs here. And that's magnesium chloride. So that's one reactant. That's the first reactant. No, we're not done. So remember, we have 2 reactants. we just determined how much of one reactant we need. Now we need to determine how much of the second reactant we need. So we're still trying to produce 2 grams of silver chloride. So we still have to divide by the molar mass of silver chloride. Now our mole-to-mole ratio is going to be different because now we're trying to get silver nitrate. So what's our moles of B going to be on this one? So now we have 2 moles of silver nitrate over 2 moles of silver chloride. And then, so we've converted from grams of silver chloride to moles of silver chloride, and now we're dealing with moles of silver nitrate. So we need to get the mass of silver nitrate. So what's the molar mass of silver nitrate? I got 169.872. Anybody else get 169.872? All right. So now we've converted from moles to grams of silver nitrate. We just need to punch it in the calculator, just like before. I think that's right. Yep. 2 divided by 143.321. I guess you could do 2 divided by 2 right there. .37 grams of silver nitrate. So you have 2 reactants. You'll get 664 grams of magnesium chloride and 2.37 grams of silver nitrate. So that's it.